Heart arrhythmia detection and its analysis using MATLAB. Abstract: the heart condition is monitored by the electrocardiogram, ECG, signal. The abnormal conditions of the heart results in the artificial arrhythmia. This paper deals with the study and analysis of ECG signal by means of MATLAB tool effectively. The study of ECG signal and arrhythmia detection and analysis includes generation and simulation of ECG signal, real-time ECG data analysis, ECG signal denoising and processing using filters and detrending technique, detection of QRS peaks and its locations, calculation of RR and QRS interval, calculation of heartbeat rate using the MATLAB software, detection of any abnormalities in ECG by using the above parameters. This way the person having abnormal rhythm is detected. Previous analysis of arrhythmia is done only based on heart rate, but in this paper even other parameters RR and QRS intervals are calculated and are used along with heartbeat rate to detect any of the abnormalities in ECG. The accuracy and precision of this analysis is calculated and shown. Thus, the proper utilization of MATLAB functions and toolbox can lead us to work with the ECG signals processing and analysis in real time and simulation done with good accuracy and is convenient. Thus, the method serves as an easy technique for studying cardiac abnormality. Keywords: arrhythmia, ECG analysis, RR interval, QRS pattern, denoising filters, detrending heartbeat rate. Introduction. ECG is the most easily accessible bioelectric signal that provides the doctors with accurate and reasonable information regarding heart condition of the patient. Many of the cardiac problems which persists are visible in the form of distortions in the electrocardiogram, ECG. The major tasks involved in diagnosing the heart condition is analyzing each heartbeat and calculating the heartbeat rate and correlating the distortions found therein with the various heart diseases. ECG signal consists of some few main components such as the segments, intervals, and waves which are studied and evaluated based on the size and duration time or interval. The heart rhythm is determined by the detection and analysis of these different components. The abnormal rhythm of the heart is called arrhythmia, or dysrhythmia, and is indicated when above-mentioned components vary with the expected norm. Any deviation from the predefined pattern of the in terms of amplitude or time duration indicates the abnormality in functioning of the human heart. The typical ECG signal consists of P, QRS, T, U components. The QRS complex a vital role in identifying the problems that occur with the functioning of heart. If any problems are associated with the heart, then the QRS complex lengthens or widens or becomes shorter. The abnormalities in the rhythm are mainly observed with the help of parameters QRS duration, RR interval, and heartbeat rate. 3. Process involved. A. Noise reduction. Signal processing is a major challenge as the actual signal value will be 0.5 mV in an offset environment of 300 mV. The factors such as the AC power supply interference, RF interference from surgery equipment, and implanted devices like pacemakers and physiological monitoring systems can also interference the noise to the ECG signal. So, it is important to remove the noise from the ECG signal before it is analyzed and processed, else may cause deviations from the actual and correct readings. The main sources of noise are listed below and are removed by using the following filters mentioned. Baseline wander noise is removed using high-pass FIR filter with cutoff frequency 150 Hz and a low-pass FIR filter with cutoff frequency 0.05 Hz. Power line noise is removed using 100 coefficient and 1000 coefficient band stop FIR filter of cutoff frequency 59.955 to 60.005 Hz. MATLAB syntax for designing the above high-pass FIR filter. Y = Y plus filter, band stop _100, 1 val. B. Parameters used and its calculation. The parameters used for the analysis of the arrhythmia is the QRS complex, which is calculated with the help of QRS duration, RR interval, and heart rate. The process to find its calculation and location is described below. Calculating R, Q, S peak, and its location, the standard QRS interval is considered as 0.094, and in order to access the samples and round them to the nearest integer less than or equal to that value. MATLAB syntax. Sample = floor, sampling frequency, asterisk, standard QRS interval, /2. QRS duration. The duration of QRS complex of ECG can be calculated by dividing the number of samples between the QRS complex and the sampling frequency of the signal. By calculating the duration, we can know whether the signal is abnormal or normal. As per the standards, the standard QRS duration of a normal ECG signal ranges from 0.06 to 0.10 seconds. RR interval, this is the longest amplitude peak in ECG signal. It is calculated by dividing the number of samples between two R peaks and sampling frequency of the signal. This plays a vital role in finding the abnormalities of a signal. For calculating the region of RR and QRS, for loop of length with range from 1 till the length of the R1 and the difference of the consecutive samples is the RR interval are used. RR region, K, equals R location, K plus 1, R location, K. QRS region, K, equals S location Q location. For calculating the RR and QRS intervals, mean of the normalized locations of R and QS are used. RR interval equals mean, RR region slash sampling frequency. QRS interval equals mean, RR region slash sampling frequency. Calculation of normal and abnormal heartbeat rates. Heartbeat rate equals 1/60th, asterisk RR interval. Normal heartbeat rate equals heartbeat of patient whose actual is 1. Abnormal heartbeat rate equals heartbeat of patient whose actual is 0. Mean normal heartbeat rate equals mean, heartbeat of patient whose actual is 1. Mean abnormal heartbeat rate equals mean, heartbeat of patient whose actual is 0. Distance normal equals absolute, normal mean normal heartbeat. Distance abnormal equals absolute, normal mean abnormal heartbeat. Detection of QRS peaks of 100 m.mat. Sampling frequency equals length, value, slash time. Where value is the sample of a signal at a particular time instant. Then the base wander line noise and power line noise of the data sample are removed as described in the above section. Detrending of noise removed data sample. Linear detrends are removed from the data sample. Detrended data sample equals noise removal data sample signal with trends. The signal is now smoothened using Schoenfeld filter. Detection of arrhythmia, the sm.info and the small mat formats of 4 signals are loaded. Now the ECG signal corresponding to the normal and abnormal behavior we may detect the presence of arrhythmia in a patient. Conclusion. The heart arrhythmia detection is successfully done considering all the factors. All the necessary parameters P, QRS, T, U components are analyzed and are used for detection of any abnormalities in the heart. Most of the cardiac problems persisting can thus be identified due to the irregularities in the ECG of the person by not only calculating